All right. So, the geometric sequence, what's the difference? Well, we've talked about the arithmetic. The arithmetic was when we start with a number and we add on the same amount. So that's an example of arithmetic. Geometric is when we start with a number and we multiply by the same amount. So an example of a geometric would be like 2, 6, 18, 18 times 3, 54. So see what's happening here? Arithmetic, we're adding on the same amount. Geometric, we multiply by the same value. The common ratio is the multiplier. It's also going to be the same thing as the second term divided by the first term. That's going to equal R. Or the third term divided by the second term. That's going to equal R. So really I could say it's going to be A sub n plus 1 divided by A sub n. That's going to equal R. Do you understand how that's the same thing as the others? This is saying 1 past divided by the 1 before. Here's our formula. This is the third formula you have to know. The first formula we learned was to find the nth term of an arithmetic sequence. The second one we learned was to find the sum of that arithmetic sequence or series. So this is how we find the nth term of a geometric sequence, right here. So this is telling me that the nth term of a geometric sequence with the first term of 2 and a common ratio of 3. That's what I just did here. First term is 2, the common ratio is 3. We now have a formula that we can do on this. So it's going to be A sub n equals A sub 1, which was 2, and then the R value raised to the n minus 1. So now I could use this and I could find the sixth term if I wanted to. To find the sixth term, it's going to be 2 times 3 to the 6th minus 1. So that's going to be 2 times 3 to the 5th. And then I can just do that. So 2 times 3 to the 5th power gives me 486. That's the sixth term. The other way I could have found the sixth term, though, is here's my first, second, third, fourth. So I can take that fourth term times 3. There's my fifth term times 3 again, and there's my sixth term. So we have two ways we can find that sixth term. All right, so now I want you guys to come up with the rule if I give you this pattern. So let's say we have 3, 6, 12, 24, ... What would be A sub n? What would be that rule? Chloe?
3 times 2 to the n minus 1.
Good. She's right. So all we had to do was plug in A sub 1, find our R value, we're multiplying by 2 every time, and then to the n minus 1. And then if I asked you to find the sixth term, go ahead and find that sixth term. And rather than using the formula, I'd probably just do times 2 and times 2 again. Kara, what did you get?
Times 6.
Mm-hmm. All right, so now let's go over to the practice problems on page 229. We're going to tell whether or not the sequence is geometric. We do have to be careful on this. We have to make sure that we're always multiplying by the same value. So I can see here I'm multiplying by 3, multiplying by 3. I have to check that though. I want to make sure that 36 times 3 is 108. And then if I do times 3 again, I do get 324. So yes, it is. And in fact, I would say R equals 3 in this case. What about this one? Evan, what do you think? Yes or no? Why not?
Because it's just subtracting by 5.
Right. So that's going to make it actually arithmetic with a D value of -5. See, we use D when it's arithmetic for difference, and we use R when it's geometric for ratio. All right, taking a look at this one. I'm just going to check for that. So should be 6. So once I know that the ratio should be 6, I'm just going to keep multiplying. Times 6 should give me the next one, and it does. Times 6 should give me the next one, it does. Times 6, yes. So yes. What about on this one? What do I multiply 3 halves by to get -3/4? Tyson, what do I multiply 3 halves by to get -3/4? Yep. So we think R is -1/2. We're just going to check. If I multiply this by -1/2, that works. Yep. And it works all the way along. So yes, it does. All right, so now we're back to writing rules for the sequences. Okay, so I'll do, first one's pretty easy. Let's go and I'll do the second one with you. So to find our R value, I can do -6 divided by 3. That gives us -2. So the formula is going to be A sub n equals A sub 1 times R to the n minus 1. And so that's going to be our formula. Then they ask us to find A sub 6. 6 minus 1 is 5. What's 2 to the 5th, guys? 32, so it would be -32 times 3. So that's going to be -96. Works the same way with fractions. Let's look at this one. What's the R value going to be here? Dan, what's the R value? All right, so R is 5 halves. So to come up with our formula, it's going to be A sub n equals 1. I don't have to write that. 5 halves to the n minus 1. So then to find A to the A sub 6, I'm going to have to do 5 halves to the 5th. I don't know what 5 to the 5th is. That is 31/25. And then I have to do 2 to the 5th, and that's 32. Okay? Easy enough? It would work the same way with decimals. Let's go over to the back. Okay, this one's a little bit tougher. Write a rule for the nth term where A sub n equals A sub 8 rather equals 384 and R equals 2. So I'm going to write my formula. A sub n equals A sub 1 R to the n minus 1. What is n in this case, guys? Right here. 8. So I know when n equals 8, here's what I would get. A sub 8 equals A sub 1 times R to the 8 minus 1. Well, I know A sub 8. A sub 8 is 384. A sub 1, I don't know. R is 2 to the 7th. So I can now solve this, and I can figure out what A sub 1 is. So I have 384 equals A sub 1, times 2 to the 7th. Well, I know 2 to the 5th is 32, so 64 would be 128, wouldn't it? And then divide by 128. And so what's A sub 1 going to be? 3. So now I know A sub 1 and I know R. So once I know A sub 1 and R, I can write the equation. A sub n equals a sub 1 times r to the n minus 1. So that's going to be our formula. And I'm supposed to graph this, so I need to find my first 6 terms. Well, I'm going to find the first term. I already know it. It's 3. Oops. I need to have my nth term. So when n is 1, a sub n is going to be 3. When n is 2, I'm just going to keep multiplying by 2. It's 6. That's 12. That's 24, 48, and 96. There's no sense using my formula when it's just an r value of 2. It's easy enough. So now we're just going to graph these. So let's see, we have to go up to 96. We might want to make these go by 10. So 10, 20, 40, 60, 80, 100. So we got 1 is 3, 2 is 6. I'll be right about there. 3 is 12. 4 is 24. 5 is 48. 6 is 96. So do you remember how our arithmetic looked? What was the arithmetic when we graphed it? It was linear, wasn't it? This one's definitely not linear. What's this one? Exponential. Would you rather have linear growth or exponential growth if you're talking about money? Exponential for sure, yeah. All right, I'm going to show you one of these and then I'm going to ask you to try one. So, in exercises 10 and 11, write a rule for the nth term of the geometric sequence. So they tell me a sub 3 is 54 and a sub 6 is 1458. That's kind of hard to do. Because in order to write my formula, I have to know 2 things. I have to know a sub 1 and I have to know r. And I don't know either one of them. So what I'm going to have to do is think about the fact that they're telling me that when n equals 3, I know something about that. And when n equals 6, we know something about it. So when n is 3, what is a sub 3? 54, so I can say 54 is going to have to be equal to a sub 1, I don't know, r, I don't know, but what's n in this case? 3. So 3 minus 1 is 2. So this is one equation I know. I can't solve this equation though because I have 2 variables in one equation. If I have 2 variables, I have to have 2 equations. So I now have to use this and make an equation. So what is a sub 6? What's the answer to a sub 6? All right, 1458 has to equal a sub 1, I don't know, r, we don't know, n in this case is 6, so to the 5th. Now look what I have. I have 2 equations. I want to be able to find out what a sub 1 is and what r is. So here's what I have to do. I'm going to solve this for a sub 1. So I'm going to divide both sides by r squared. So a sub 1 is going to equal 54 over r squared. I'm also going to solve this one for a sub 1. So what's a sub 1 here going to be? A sub 1 is, all right, 1458 over r to the 5th. Well, if a sub 1 equals this and a sub 1 equals this, what can I say about these 2 things? They have to be equal to each other, don't they? So I can now put 54 over r squared must equal 1458 over r to the 5th. What do I do to solve this kind of problem? Cross multiply, right? So I'm going to get 1458 r squared equals 54 r to the 5th would I do now? I want to get my r's together and my numbers together. So, Alex? Okay, so I'm going to divide both sides by 54. And 1458 divided by 54 is 27. So I have 27 here. So I have 27r squared equals r to the 5th. How do I solve that now? What do I do to get the r's together? Divide by r squared, right. So what is r to the 5th divided by r squared? R cubed. So now I'm going to do the cube root. So r is going to be 3. So now I know r. Since I know r, I can go and plug back in and find a sub 1. I can plug in here. That's kind of hard to do, though. Plug in here. 54 divided by 3 squared. What is it? What's a sub 1? So a sub 1 is 6. And so now I have enough information to write my formula. So it's going to have to be a sub n equals a sub 1, which is 6, times r to the n minus 1. That's going to be the rule on that. Kind of tough, but this is what we did again. We set it up for when n is 3, n is 6, substituted in, solved each of them for a sub 1, set them equal to each other, solved for r, plugged that back in so that we could find out what the other value was, what the a sub 1 was. Okay? Questions? All right, I want you guys to try number 11. The first 3 people to get it right, I'll give you an extra point.